We are on page 157, and that starts the top of the page with a your turn question. I would like for you to try question number 3, and when you're ready to check your answer, resume the video. Number 3, there are 156 players on 13 teams. How many players are on each team? Blank players per team. This is a unit rate question because if you take the information given to you and you record it as 156 players over 13 teams, it's not a unit rate because we have the second term is not 1. And so that's a reminder of what you're supposed to do. A unit rate is to make the second term 1. Well, how would we do that? Well, if you wrote this is going to be equal to a simplified version, we don't want to know how many players are on 13 teams. We want to know how many players are on one team. And so if you understand what a unit rate is, you can remember what the operation is. If you look at this, you think, well, how do I get from 13 down to 1? Well, you would divide by 13. And that's exactly what we do. We divide by the second term. If you divide 13 by 13, you get one team. Then you have to divide 156 by 13 to get the first term. So I'm going to do that long division style. 156 is the dividend, 13 is the divisor. You could also use a multiplication chart. This would be a great problem for a multiplication chart. 13 goes into 15 once. 1 times 13 is 13. Subtract and get 2. Bring down this 6. 13 goes into 26 twice. 2 times 13 is 26. And you get 12. And what is that? It's 12 players per one team. You could, with a calculator, check your answer very easily simply by doing either 156 divided by 13, or even better, you could do 12 times 13, and you expect it to be 156. Okay, let us check out a word problem. The title is Problem Solving with Unit Rates. You can solve rate problems by using a unit rate or by using equivalent rates. So example 2, I'm going to point out to you, and I hate to overcomplicate things, but I'm going to point out to you that this question here, I'll highlight the question as I read it. And I'm going to point out to you there's 2 ways to solve. I'm going to show you both, and there's opportunities to use each of these. And they should make sense mathematically, so I hope it doesn't stress you out that there's 2 methods. At a summer camp, the campers are divided into groups. Each group has 16 campers and 2 cabins. How many cabins are needed for 112 campers? So that's the question, and we'll probably refer back to it. And then all of this text here shows 2 different methods. But what I'd like to do sometimes is I kind of pretend that we don't have this information, and I want to show you the way that I would solve this. So I'm going to go ahead, I'll leave that method 1 right there, and this first method we're going to define as using the unit rate. So method 1, I'm going to call unit rate, and I'll show you what I would do on this problem. So I go and reread and find the information given to you, and the basic information is that 16 campers could fit into 2 cabins. And there's some more information later in the question, but I don't actually need that yet because of what the first method is called. It's called unit rate. Right now I don't have the unit rate, so the first thing I'm going to do is quickly compute the unit rate. If 16 campers can fit into 2 cabins, I can simply divide by 2 and figure out that 8 campers are in 1 cabin. This information is actually more helpful to me because now it's less computing when I try to figure out how many cabins are needed for 112 campers. There's 8 campers per cabin, and what I actually need is, I'm going to hit equals again here, what I actually need is to house 112 campers. So how I set this up is I put 112 campers over question mark because the question says how many cabins are needed for 112 campers. Now what I hope you can do is ignore this term because I found its unit rate, and now ask yourself, well, if 8 campers can fit in 1 cabin, how many cabins do I need for 112 campers? I hope you could identify this as division. In other words, how many times does 8 go into 112? 8 times an unknown is 112, and that can be solved just through long division. 112 divided by 8 Once again, a multiplication chart would help you on this. 8 goes into 11 once. 8 goes into 32 4 times. 8 times 14 is 112 evenly. So what is 14? Well, in this case, 14 is the number of cabins needed to house 112 campers. Way you could check that would be to, first of all, divide 112 by 8. You get 14. And then even more importantly, you could say, well, 8 campers can fit into one cabin. So if I multiply that by 14 cabins, I should get 112 campers, which I do. Okay, so I like the unit rate method often, but sometimes it's actually not the fastest way to solve. I want to point out to you method 2 here. So what I'll do is remove my whiteboard and turn my page, and I'll read method 2 with you real quick. Maybe I'll grab a whiteboard first. Method 2 is called using equivalent rates. Now, I don't know, this might look just a little bit confusing, but what I'll try to do is explain the math that's actually happening here. So method 2 is use equivalent rates. I'll go ahead and title my board here. It's important to me, because when I'm going to be teaching this, it's important to me that you kind of know the difference. So we're going to call this one equivalent rates. And if you reread the question, I almost need to go back to it. If you read the question, it says something to the effect of 16 campers can fit into 2 cabins. So you start with that, again, just like last time. 16 cabins can fit into 2 campers. I'm sorry, 15 campers can fit into 2 cabins. Now here's where my strategy is going to be different. Last time I simplified or divided 16 and 2 to get down to 8 campers per cabin. This time I'm going to cut straight to the information in the question, which was how many cabins are needed for 112 campers. So what I'm going to do here is I'm going to set up an equivalent rate where I need to put 112 on top, because when I set my problem up originally, I put the campers over the cabins. Notice when I set it up over here, I have campers to cabins. So on the right, I need to do campers to cabins. So I'll write cabins right here, and we're pretending we don't know the right answer, even though we already got it from method 1. Now here's the math. If you examine this right here, it's kind of like if we had a simpler problem. Maybe in the ratio lesson 6.1, we might have set up a similar problem. I'm going to just use some really simple numbers here, and I'll erase them in just a minute. Where we might have had something like 4/5, and that would be equal to something like 8 over, and then a question mark. Well, if you look at that, 4 over 5 is equal to 8 over blank, you instantly notice that you double the 4, and then you would double the 5, and so your answer would be 10, 8 over 10. This is the same math here, it's just more complicated. A lot of kids don't recognize it, but if you looked at a multiplication chart, I think you'd see the answer pretty quickly. If you looked at your 16s, 16 times an unknown is 112. If you look at your multiplication chart, you'll see that it's 7. And if you multiply one term in a rate by 7, you have to multiply the other term in the rate by 7. So you could simply get the answer by doing 2 times 7 is 14 cabins. So you get the same answer, 14 cabins, either way. 14 cabins for 112 campers. Method 2 is a little faster, but you have to be able to notice the math that's happening there, which is times 7. Method 1, finding the unit rate, that's an excellent method, just might take a little bit longer.